Welcome to this video on dot plots and the shape of distributions. By the end of this video, you should be able to describe the shape and distribution of a data set by using a dot plot. You should be able to differentiate between skewed left, skewed right, and symmetric and uniform data distributions, and you should be able to make a dot plot of a given data set. Okay, so a dot plot is really just a way to tally how many times an event happens. So when we're going to take this set of data and we're going to create this dot plot over here. When I'm looking at this, I'm noticing that the smallest number is 9 and the largest number is 16. So I'm going to number these 9, 10, 11, 12, 13, 14, 15, and 16. So this is our puppy weights in pounds. So we want to take each one. For every point, we're going to put a dot over here. Just be very careful when you make each dot. You want to make them about the same size. That way when we get them all stacked up, they're equivalent to each other, so we're able to see which ones are taller. So our first number is 12, so above 12 I'm going to put a dot. The next number is 9, so above 9 I'm going to put a dot about the same distance as I did from 12 and about the same size. I had a number 9, another number 9, and then a number 12. And a number 12. Okay, so by keeping them the same size and shape and keeping things even, I can quickly see that there's more 12s than 9s without having to actually count them. Then we have an 11, we have another 12, a 15, 10, 13, 9, 12, 13, 15, 11, 10, 12, 10, 16, and one final 12. Okay, so when we look across here, like let's look at the second point. You notice how they're all at pretty much the same height going across. That's what I'm saying. We want to keep them equal and even to each other. So we can tell just by looking at this. Obviously there's more 12s than any other weight, 12-pound puppies. 9 and 10 is the same. We can see that their tops are even without actually having to count all the dots. Okay, so when we make a dot plot, the data will take on a different shape. As we stack up all these points, we're going to get a shape to our data. It gives us a good information of kind of what's happening with our data. So there's 4 main shapes that we want to look at. Okay, our first one is called skewed left. The distribution is skewed left when most of the data values are right. Okay, and so the left-hand side is called a tail. So if you kind of think about this, it kind of looks like a whale. So the skewing is where the tail is. Most of the data points are up here higher. So you could think of this as maybe 0, 1, 2, 3, 4, 5, 6, 7. Most of the data points are higher, but we have some that are lower. We could even have outliers that pull the data this way to give it this tail. Okay, so outliers might be responsible. You have more higher values. I'll just use an arrow. More high values, and you have lesser of the lower values. So that's going to skew your data to the left. Skewed right is just the opposite. It has the same overall shape. It looks like a whale. The tail is where the skewing is, because most of the numbers are over here. And in this case, most of the numbers are in the lower area. Okay, so this could be caused, outliers could cause this. It doesn't have to be an outlier, but an outlier could pull your data that way and create a tail. And in a skewed right, you have more lower values. Okay, so these are lower scores. Say these are scores, these are lower, and these are higher scores. This could be like a soccer. In soccer, it's more likely to have a lower score and less likely to have a higher score. So you had a few that made a higher score, and that's where that tail came in. Okay. The third shape I want to talk about is symmetric. So every time I look at these, I always think, what if I threw a blanket over it? What would it look like? So you just want to kind of think about throwing a blanket over it. What would it look like? Do you see how this is? It's peaking in the middle, and it has kind of the same going down on both sides. So it's going to be symmetric when the data on the left is approximately the mirror image on the right. So I could fold this in half and center here, and it would pretty much line up. This is not the only way we could be symmetric. We could have a data set that looks like that, and it's still symmetric, because if I folded the graph in half in the middle, these would line up with each other. Okay, another one that you could see is you could see almost like a V shape. You fold the graph in half and they're going to line up with each other. So this is not the only symmetrical, it's probably the most common symmetrical that you're going to see, but it could be these other shapes too. My last one, if I throw a blanket over it, it's pretty flat across the top. It's not exact, but it's pretty flat across the top. We call that uniform, when there's approximately the same number of data points in each section. Okay. This is also symmetric, because if I folded it in half, it would also match up. So it's uniform and it is also symmetric. So let's try a couple of these out and see how we do. So we're going to make some dot plots, and then we're going to describe their shape. Okay, so I'm going to help you with your scale. I'm going to count by fives: 55, 60, 65, 70, 75, 80, I might be going a little too wide, 85, 90, 95, 100. Okay, so there's where we're going to put our dots, and then once we've got our scale, we just go above each dot and we make our points. So go ahead and pause the video and put your points on. All right, I have all of my points on here. Right, and I'm noticing there's a group and kind of a gap and then another group. If I throw a blanket over this, just always think about throwing the blanket over it. What's it going to look like? I have that. If I folded the graph in the center, it would be mirror images of each other. So this is symmetric. So its shape is symmetric. Okay. For our next one, we're going to plot all of these points. Your scale that you're going to want to use here is 1, 2, 3, 4, 5. Go ahead and pause the video and put your data points on. So here's our dot plot of the data set of the goals scored by the hockey team in their first 20 games. If I throw that blanket over it, you will notice it is pretty flat across the top. So that's going to make this uniform. And remember, the uniform are also symmetric, because if I folded it in half, it would be a mirror image. So it'd be uniform and symmetric. Okay. Go ahead and try the last one. You can count by ones. I'll help you get your scale going. So we have 76, I counted by twos, 78, 80, 82, 84, 86, 88, and 90. So go ahead and pause the video, put all your dots on there, and go ahead and try and determine the shape also. Okay, so your dot plot should look something like this. Go ahead and throw your blanket over it, and it should loosely follow. All right, so take a look at that. We have more data points because it's taller over here in the bigger numbers and less in the smaller numbers. Think about that's where your tail is for your whale. Which side is the tail on? It's on the left, so this is going to be left skewed. We could have outliers, or anything can pull your tail over like that, but most of the numbers are over here on the right and only some of them are on the left. All right, so let's talk briefly about measures of center, which we've already talked about in range, but specifically with dot plots. So now let's go ahead and find these measures that we've been finding before using our dot plot. There's a couple different ways we're going to do this. I'm going to show you one way. So I like to list out the numbers. So there's 190. There are 3 91s, so 91, 91, 91, 2 92s, 193, and 2 94s. So I got those numbers from my scale down here and just counted the dots so I knew how many times to write them. Okay, so there is 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. That means there's an exact middle because it's odd. 1, 2, 3, 4. This is my middle number. And I'm going to verify that it's the middle number because there's 4 numbers to the left and 1, 2, 3, 4 numbers to the right. So I know my median now. It's 92. Okay, for the mean, we're going to add up all of these numbers. And when you add them all up, you get 828. And we said, and there are 9 of the numbers, we have already counted them. So 828 divided by 9 gives us a mean of 92. It just happens to be the same as the median. And then our mode, when you list out the numbers, it makes it easy to see, but we can also see here, the number with the most dots above it is 91. So our mode is 91. Because we had 3 of them. And then your range is just your largest number minus your smallest number, so our range is 4. Okay, for number 5, go ahead and find the mean and the median. Pause the video, go find the mean and the median, and then we're going to answer the question using that information. All right, so when I have my numbers listed out, and I remember there's more than one way to do this, I'm just showing you one way. There are 10 numbers. It tells us that in the problem. 1, 2, 3, 4, 5. It's an even number of numbers, so we're going to fall between 2 numbers. I'm going to verify I put that in the right spot. There's 5 to the left, 1, 2, 3, 4, 5 to the right, so I know I'm right in the middle. So to find the median, the number that's halfway between 26 and 26, well, that's 26. Okay, so our median is 26. Let's find our mean. So we're going to add up all of the numbers, and when you add them all up, you're going to get 270, and there are 10 of them. So our mean is 27. The question asks, find the difference between the mean and the median number of pages she reads each night. So it says the mean and then the median. So that's the order we're going to subtract, and we know it's subtracting because it says difference. So the mean minus the median, there's a difference of 1. All right, hopefully that was helpful. Let me know if you have any questions, and I'll see you in class.
Yeah.